Hello guys, welcome back to Organic Chemistry Exams Prep. This is Dr. Kulbhushan. Currently we are discussing the organometallic reagents. Organometallic reagents have a carbon metal bond. The metal here could be lithium in case of organolithium compounds. It could be a copper in case of Gilman reagents, and in case of Grignard reagent it is magnesium. So this carbon metal bond being very polar, it's got some ionic character to it. So the metal being electropositive could be considered as partial positive and the carbon is partial negative. So that's the reason that our organometallic compounds are nucleophilic in nature. So the nucleophiles will react with electrophilic centers or species. In this case, they would react with electrophilic carbon of aldehydes and ketones, esters, acyl halides, and epoxides. So the first type of reaction that we saw were the reactions of Grignard reagents with aldehydes and ketones. So Grignard reagents would add on aldehydes and ketones to form primary, secondary, or tertiary alcohols. In case of formaldehyde, they form primary alcohol. In case of other aldehydes, they would form secondary alcohols, and in case of ketones, they would always form tertiary alcohols. The second type of reactions were the reactions of Grignard reagents with esters and acid halides. The Grignard reagents would add twice on these compounds. The reason is that the intermediate compound that forms is a ketone, and ketones are even more reactive than corresponding esters or acid halides, and that is the reason that Grignard reagent would add twice on them to form tertiary alcohol. Now, the third class of reactions of Grignard reagents are reactions with epoxides. They are also known as epoxide ring opening reactions to form alcohols. So this reaction is very important because here we are forming a new carbon-carbon bond on an sp3 carbon, which means that we are increasing the length of the carbon chain. And these reactions are important because in organic synthesis our goal is to make bigger, more complex molecules containing the functional group so that they could further be applied to different scenarios, to different applications. And one of those applications are applications of organic compounds in pharmaceutical reagents. They could also be used in some organic photovoltaic solar cells, or their applications could be just simply understanding the fundamental science of organic synthesis. Now in this reaction, here we have an example of a symmetrical epoxide. So if you have a symmetrical epoxide, it's got two carbons, so both carbons are equivalent. So in this reaction, the Grignard reagent can approach either carbon and you would form the same product, primary alcohol. In case of an asymmetrical epoxide, you are having here two choices. So this one is our primary carbon and this is our secondary carbon. So the primary carbon is considered a carbon that is connected to one carbon or no carbon, and secondary carbon is a carbon that is connected with two carbons. Here we have this primary carbon which is less hindered, and this carbon here is more hindered. So less hindered versus more hindered. Now our Grignard reagent is nucleophilic, and the carbon that is connected to epoxide is electrophilic. So we have two options, and now as you see the product, our product is a secondary alcohol, which means that our nucleophilic Grignard reagent has been connected to this primary carbon. And the reason for that is, if you see the mechanistic steps, this is simply a substitution nucleophilic second order reaction. And we know that SN2 reactions, in SN2 mechanism, the nucleophile approaches the sterically less hindered carbon. And so this SN2 reaction, this step, it's got two steps. First step is the substitution step, the second is the neutralization step. So the first step is the nucleophilic substitution. The second step is the neutralization. So first step is the slow step. And the second step, acid-base reaction, is the fast step. So the slow step of the reaction mechanism is the rate determining step, and the first step is not rate determining step. So in this mechanism, the nucleophile attacks the carbon which is less sterically hindered. Once the nucleophile attacks, the leaving group leaves. So this epoxide opens and you form the tetrahedral intermediate, which is an alkoxide ion. So this alkoxide ion has an oxygen with a negative charge, which is a very good base. So in the neutralization step, the base takes a proton from the hydronium ion that is present due to the acid workup to form the product, which is a secondary alcohol. So now these type of reactions are also important because we can have a selective stereochemistry by using epoxides that are optically active. And so we can see some examples, but we'll do that in the section of questions answers.